All right, hello, seventh graders. Welcome back. So this is chapter 1, lesson 6. And if you are following along in your book, it's on page 55. We're still working with proportions. Today we're going to talk about solving proportions. And we're going to do a couple definitions at the beginning like we have been. But as always, the first thing I'd like you to do to write your name. Oh, I need to sharpen this pencil. And then please write the date. So a proportion is an equation stating that two ratios or rates are equivalent. Again, sorry about my hand blocking it out. An equation stating that two ratios or rates are equivalent. So an example could be AB equals CD. I know since last year at the end of 6th grade math, you guys missed out on a little bit because of remote learning and how chaotic the situation was. So we're going to try to see if we can fill in those gaps or see what you already know. But if you are confused about something that goes on in this video that you think you should have already learned or didn't get to cover because of the situation last year in the spring, just unpause, ask your math teacher, say, I never actually learned about that. Can you explain it more in depth for me? And they will hopefully be able to do that. So the first thing that I wanted to clarify is when you see letters in math, I know this isn't something that you see a lot until probably 7th, 8th grade maybe. Those letters are called variables. So I'm just going to write that on a little side area over here so people can remember that. So variables. You could say variables are x, y, z, and you could keep going. It could be any letter. It doesn't have to be x, y, and z. It represents an unknown value. That's just like a little side note. Represents an unknown, we'll say quantity. Oops, I'll move my little camera. So that's kind of a little important keynote. So these letters or variables, which is that I'm going to start referring to them now, these variables are representing an amount that we don't know yet. So let's try with an example once I get into cross products. So cross products right here are products of AD BC are cross products. Cross products of any proportion are equal. And I'll give you guys a second to write that because I know I was blocking the entire thing, so sorry about that. So cross products. So the products of A and D here and B and C are cross products. Cross products of any proportion are equal. So looking at an example again, same idea. So when I say A over B is equal to C over D, that's because if you multiply the numerator and denominator together, the numerator on the first fraction and then the denominator on the second, so you're multiplying across. So A times D, I would just write AD. My A's are kind of weird. I shouldn't write them like that. That's going to be equal to B times C. So it's equal to B times C. And notice here that when I multiplied them, I didn't have to put a multiplication sign. I just multiplied them. And that's going to happen when you see variables. But if you like to write a multiplication sign, you're obviously welcome to. Just know that if I don't, that's why. This operation here is going to be multiplication. So if I tried it with numbers that we do know the value of, let's say 6/8 equals 3/4. Let's see if this is true. So if we multiply 6 times, so I'm going to write it out. So 6 times 4 should be equal to 8 times 3. And you'll also, again, you'll notice that right here, I didn't actually write out the multiplication sign. I didn't do a times symbol or dot, which you might see sometimes as well. So 6 times 4, you get 24. And 8 times 3, you also get 24. And 24 does equal 24, so that makes sense. So whenever you have two proportions, if their cross products are equal, that means the proportions are equal. They're equivalent. Oh, I don't like how this is not straight at all. All right, so now we're going to go to the bottom, and we're going to do more practice with this, don't worry. But now we're going to look at the real world link together. I'm like holding my camera on a candle, and it is going to fall off the table. I need to move my thing. Okay, so the real world link. Katie and some friends want to buy fruit smoothies. They go to a health food store that advertises a sale of 2 fruit smoothies for $5. Fill in the boxes to write a ratio that compares the cost to the number of fruit smoothies. All right, so first thing I look at is I say, okay, we're comparing the cost to the number of fruit smoothies. So it's 2 fruit smoothies for $5. So right away I'm like, okay, $5 for 2 smoothies. From there, I want to find the unit rate. So how do I find a unit rate? So we did do that already. So we should remember that unit rates have a denominator of 1. So we divide the numerator and denominator both by whatever number is in the denominator. So here we have a 2. So to get a denominator of 2, we should divide by 2. So 2 divided by 2, we get 1. So it'd be 1 smoothie. And 5 divided by 2, you should get $2.50. And I'm just going to do a little bubble because that's very important for the next question. So that's our unit rate. We want to know how much money one smoothie costs. All right, so now if I'm looking at question 2, suppose Katie and her friends buy 6 fruit smoothies. Complete the ratio that compares the cost to the number of fruit smoothies. Okay, so here we're just doing 6 smoothies. We know one smoothie costs $2.50. So really we're just multiplying 6 times 2.5 or 6 times $2.50. When you multiply that out, you should get 15. So it would be $15 for 6 smoothies. And then if we look at the last question here, it says, is the cost proportional to the number of fruit smoothies for 2 and 6 smoothies? So what we want to do here is we want to set up the ratios as fractions. So we're going to say, okay, $5 for 2 smoothies if it's equal to $15 for 6 smoothies, and I'll write, I'm gonna write smoothies really small. I should have made room for that. Because you want to make sure that you keep in mind that the units are really important. You don't want to forget those. Once you get in the habit of leaving them, you're going to start forgetting them. So now what should happen is we cross multiply. So 5 times 6 should be equal to 15 times 2. 15 times 2. So 5 times 6 is 30. And then 15 times 2 is also 30. So yes. So, and it says explain. What you would write you would say, let's see where I've run. I guess we'll do it over here. You would say, yes, they are proportional. Because the cross products are equal. Oops. So you can see if the cross products are equal, then it's going to be proportional. If the cross products are not equal, then it's non-proportional. So this is it for the first part of the video. The second one is going to start on a little preview, even though you're jumping right into it probably. Oops. This is going to be where part 2 starts. See you in a second.